Let's look at some of these problems involving inferences based on a single sample from a large sample size. But before we do, let's look up these z alpha over 2 values that we'll be using again and again and again. So the common ones we've already looked up. They are an alpha over 2 corresponding to 90% and 95% and 99%. So if you have an alpha equal to 10, then that's a 90% confidence interval and a z alpha over 2 of 1.645. If you have a alpha equal to 0.05, then that's a 95% confidence interval. And that corresponds to a z alpha over 2, which is this coefficient you're going to be using 1.96. And finally, let's add this 99% confidence interval. That's an alpha of 0.01 and a z alpha over 2 corresponding value of 2.575. So you look these up in the table. These are common values. There's where we insert them into that formula. And that's the formula that we will use for these problems. So let's look at some of these problems. We'll do them pretty quickly. I'll just set them up for you basically. First one is 5.8, and we're interested in seeing the effect of sample size on confidence interval. So we have a mean of 33.9 and standard deviation of 3.3, and we're going to change the sample size and see what effect that has on the confidence interval. So I'll also do this in Excel, and you'll see how easy it is to do in Excel. And in the future, you'll more and more just use the computer to do these calculations. So 95% confidence interval corresponds to 1.96 times 3.3 divided by the square root of 100. And if you do the math, that's about 0.6465. In part B, you do the same thing, only with a larger sample size. So now we'll divide by the square root of 400, and you'll see that the interval is decreased slightly, and that portion, that plus or minus portion, is about half. So by quadrupling the sample size, you only decrease the confidence interval by a half. That's the effect of those square roots. So let's do problem 510 involving latex allergy and healthcare workers. We're interested in the effects of people that are diagnosed with latex allergy based on the skin prick test, and they've sampled 46 people. And they want to know the average number of latex gloves used per week by all healthcare workers with a latex allergy. And so the confidence interval that we'll create is going to give us a 95% confidence interval for the average number of latex gloves used per week by all healthcare workers with a latex allergy. So a big long description. Sample size 46, mean of the sample is 19.3, standard deviation of the sample is 11.9, and since the sample size is big enough and we don't know what sigma is, we can just use S. So here we see the target estimate. The point estimate is 19.3 plus or minus, and since it's a 95% confidence interval, it's 1.96 times 11.9 divided by the square root of 56. So just that easy. We'll do another quick one. Budget lapsing at Army hospitals. And without going into the details, we can pull out the sample size, pretty big sample size, and we can get the summary statistics, the X bar and the S. Oops, need to scooch that up just a little bit. And we are dealing with a 90% confidence interval, and a 90% confidence interval corresponds to a z alpha over 2 of 1.645. Let's quickly look at this problem 513, which deals with the mean number of blogs per site on a sample of Fortune 500 firms. So the mean number of blogs per site used for advertising, I think, was 4.25 with a standard deviation of 12.02. And we are interested in a 99% confidence interval, and so we would just once again take the point estimate of 4.25 and then take plus or minus the appropriate calculations to come up with the answer. Lastly, let's do a more complicated analysis wherein we have a bunch of data and we're going to analyze the data in Excel, and we have about 498 CEO salaries actually, and we're going to estimate the mean salary and a confidence interval associated with the mean salary based on 50, a sample of 50, randomly pulled from this set of data. And then we'll calculate a confidence interval based on a 99% z alpha over 2, and then we will see if the confidence interval that we calculated does include the true mean of the 500 CEO salaries. So let's do that next.